Alright, in this video we will be working with quadratic equations, and we will solve them by the method of factoring, and then the last one we'll actually solve with graphing, and we're going to connect these back to the graph anyway. So example 1 is x squared minus 7x equals negative 12. We know this is a quadratic because of the x squared. You have to have the x squared to be a quadratic. And that has to be the highest power to be a quadratic. So x squared, and it has to be the highest power. And the equal sign makes it an equation, because blah, blah, blah is equal to something. So it is an equation. What we want to do is we make this quadratic look like standard form. And I can do that by adding the 12 over. But more importantly, we are setting the quadratic equal to 0. When I set the quadratic equal to 0, I can do something called the zero product property. Zero product property, and I misspelled it on purpose. Zero product property says that if you have A times B equals 0, then A could equal 0, or B could equal 0. And you can actually apply this to A times B times C. You can have multiple things multiplied together, set equal to 0. Then any of the individual ones are 0, then the whole thing is 0, because 0 times anything is 0. So I'm going to factor, just like I've been practicing in other sections. And 3 and 4. And now I make the t. Zero product property, and I set each factor equal to 0, because if this first factor is 0, then the whole thing is 0. If this second factor is 0, then the whole quadratic equation is 0. So you set each factor equal to 0, and I make a t to divide it up into two parts. Zero product property. So now instead of solving this equation, I get to solve the little baby equations. So add 3 over. I like my brown pen. It's I don't know if you can see the brown, but it's a brown pen. It's for it's the time of the year it is. It's fall, so you got to have a brown pen. Even though it doesn't feel like fall here, it's kind of warm today. All right, so 3 and 4. Now let's make the connection. What did we do? We've graphed these things like this. So this is a parabola, right? And we're saying the parabola is now 0. So the y value is 0. So what is this really telling us? Well, this is telling us that these two numbers make the parabola 0. So when is a parabola 0? Well, a parabola is 0 when it crosses the x-axis. So it's the x-intercept. So it's the x-intercept of the parabola. When the parabola is equal to 0, it's where it crosses the x-axis, the numbers that make the output of the function 0. And we also call this the roots, or the zeros of the function. So that's what these are. Now let's prove that to ourselves. So I'm going to graph. Let's see how that looks. That looks pretty decent. So I'll go to y equals, clear this out. Must have been graphing another parabola, x squared minus 7x. 7x plus 12. And I'll do a zoom decimal, number 4. And it's a happy parabola because a is 1, and there you go. You can see it coming down and up and going through 3, 4. So 1, 2, 3, and 4. It crosses at 3 and 4. I can even stretch this out a little bit. Go to the window key, and let's make this negative 1.1 and 1.1. So we'll really stretch it out in the y direction. X direction I left alone, so you can see how it crosses. See, you can see how it crosses better at the 3 and 4. 1, 2, 3, 4. So it crosses at 3 and 4. So that's what we just found related back to the parabola. Excuse me. All right, example 2. So we're going to solve this one. Oh, that's what we did here. Solve. 2 answers. Solve. X squared is equal to 6x. So this is a quadratic equation. We make it look like standard form by subtracting over the 6x. we get x squared minus 6x equals 0. So now our quadratic is set equal to 0. And we're missing the c term here, but it's still in standard form. Ax squared plus bx, c is 0 equals 0. So I want to know y is 0, right? The output of the function 0. So what numbers here make the function 0? Well, I can find those out by factoring. This kind of factoring is taking out the common factor. And then we do 0 product proper t. And this right here is done. 0 is the answer. And then add the 6 over. So I get x equals 6. So the two answers are 0 and 6. So let's type this one in and see where how it crosses at 0 and 6. So go back to the calculator. That went maybe too fast there. There we got it. Okay. So this parabola is 7, 6x. And then I can delete this out. And ba-boom. I'm not going to see the whole parabola because I don't have 6 on the screen, I don't think. Well, let's look at it. It'll be close. It's going to cross at 0, and then over here at 6. Oh, there's 6 is right there. So cross at 0 and 6. Let's do zoom standard on this, which makes it be 10 in each direction. There we go. That looks really good. So it crosses at 0 and it crosses at 6. Those are the zeros of the function. All right, next example is example 3. We're going to solve this, and we get x squared plus 2x equals 24. Now, why don't you, if you're watching this for the first time, why don't you just pause it right now and try and do it? Like move the 24 over and factor and get the two answers. And let's go. Subtract over the 24. We get x squared plus 2x minus 24 equals 0. We make our two sets of parentheses. And that's a 2. So 6 and 4 are factors of 24. And we need it to be positive 6 minus 4. 6 minus 4 is the 2. Multiply those two together there. Now we do 0 product proper t. You know, it could be any kind of t. It could even be a Mr. T. See, here's Mr. T. I pity the fool who can't solve quadratic equations. Anyway, subtract 6. We get x equals negative 6. And add 4. We get x equals 4. So there's my two answers. Boom, boom. Okay, the next one we're going to solve by graphing. We're going to use the graphing calculator. So x is equal to 4. I'm going to solve this. And I have it in standard form for us so we don't have to move anything around. And here's how we do it. This doesn't factor, so we're still looking for the places where the parabola crosses the x-axis. We can do that with the calculator. All right, so I'm going to type in x squared. Oh, I could have saved some of that, not have to retype it all. Oh well. 2x minus 4. All right. Now this doesn't factor because if I do 2 and 2, it doesn't make 2, and if I do 4 and 1, it doesn't make the 2 in the middle. So this doesn't factor. Let's see what it does though. I'm going to do zoom and standard, not standard, but decimal on this one, number 4. There we go. So we don't need to really see the vertex. We just need to see where it crosses. It crosses at -1, -2, -3, and a hair more. And then it crosses at +1 and a hair more. So let's see what those hairs are. The calculator has this built-in function here to calculate the zeros of the function. So I choose 0. So under calculate, I choose 0. And I need to go to the left side of where it crosses. So here's where it crosses. And I'm just going to move it over to the left a little bit. Now it went up, but I'm basically to the left side of where it crosses because it's prompting me for where's the left boundary. And what's cool about the calculator, it puts a line there for us. Now we go to the right side, and then I've basically jailed in the place where it crosses, and then I can go back to guess. So it crosses at negative 3.24. I'll round to 2 decimal places. So x is equal to negative 3.24. Approximately, I'll use the approximate symbol. It's not exactly. We'll find the exact answer later. So the squigglies mean approximately. And then the other place where it approximately cancels or crosses is over here. So I'm going to move the, whoops, second, calculate, 0, and then move myself over, boom, right there. And here, I've jailed it in. You can kind of see where I've jailed it in between the two. And then back for a guess. So it's left, right guess. 1.24. All right. So that's the idea here. We factor and set factors equal to 0. That's called the zero product property. But what are we looking for really? We're looking for where the parabola crosses the x-axis, which are called the roots of the equation. Here's my summary page here. So like 3 and 4, these are the x-intercepts, or the roots, or the zeros of the function. And like I always say, if you can name something 3 ways in math, it's really super important. All right.